Everyone, welcome back to SF Ruby. Hey, yeah, Happy New Year, and super grateful to see all of you here today and to kind of like begin this year together officially. And we have a pretty cool plan for today. I'll begin with a few updates. Okay, I will say the setup today is a little bit tricky, but we'll figure it out. So the biggest news is Jason Swett arrived to San Francisco, and of course he couldn't just come and not speak at SF Ruby. Yay! So we'll hear from Jason in a sec. First, is this? Okay. I want to share something. Of course, we had between the last meetup and this one, there were releases of Rails 8, Ruby 3.4, and I just saw something I wanted to share yesterday. This is Maxime's post about Ruby 3.4 with YJet being not only faster, more productive, but also more memory efficient. I think this is a cool new update with the YJet team is also now, I think the team is now also optimizing for memory. So I think it's pretty cool. The other update is, yeah, we have this super cool page at SF Ruby, at rubyvideos.dev, rubyvideo.dev. And this is where you will find all the recordings, including the recording of this one. And we're also uploading the recording, let's say, every time now. Also, there's this update. There's this small Rails shop, Gusta, and they reached out proposing to sponsor our meetup. So I'm collecting ideas. What should we do? And one of the ideas, for example, yeah, just collecting ideas. We could do, for example, we could do a SF Ruby scholarship for somebody. So I'm just thinking about something more meaningful because I think you all have a lot of merch already. Assuming.
In what way do they want to sponsor?
In a way of giving us money. I mean, yeah, just let's collect ideas as a community. Because Swett? What? Yeah. Let's collect ideas. Talk to me in the break or after this, and also you can shoot me an email or reach out on those social media. That's that. The next meetup, you didn't see it, right? No. Okay. What's your favorite venue for this meetup? Productboard is, you can, no, not Productboard, except Productboard.
Second favorite then? Yeah.
Second favorite. Second favorite. Don't be shy, Meraki? GitHub? No, I mean, favorite venue, not your employer. Okay. Which one? The Moscone Center. Oh, yeah, but yeah, I'm still looking forward to the Heroku one. The Salesforce. Yeah, but we're not there yet. Yeah. Yeah, it's gonna be at GitHub. They have a pretty cool venue, and we actually had noticed that the date is February 11. 2 days ago, if you went there to Luma SF Ruby, it was February 13. We kind of had to change it a little bit. So that's going to be February 11. Please sign up on Luma. This is the only way I can reach you for free. So, yep, hope to see you there. And of course, as always, there is a link to submit a CFP. So please submit your talk proposals. If I'm not responding to your proposal, reach out using this email. And yeah, let's begin. So now Claudiu, who's leading engineering at Productboard, will tell you a bit about where we are. And we're super grateful for Productboard for hosting us for the second time this year. So let's give them a shout out.
Hey everyone, so I'm Claudiu. I'm leading the San Francisco office engineering. And how many know about Productboard before today? Okay, it's a good amount. So to be honest, I didn't know much before I joined, because what we do is actually we're trying to help companies build better products, right, for their own customers. That means we wanna help them understand their own customers and then take that information and act on it, whether they're starting planning on it and thinking how road mapping and putting everything in motion, right? So this is what we do. We've been around for I think the company officially started 10 years ago, but we launched around 8 years ago. And we launched on Ruby on Rails. We've been, it's still the biggest part of our code base, I think. And we got to be successful on Ruby on Rails, right? So that's why we're hosting. We're continuing to hire people, not only Ruby on Rails, but or Ruby, but we're continuing hiring right now. We have open role for our growth teams, and feel free. You know, this market, I just read that Meta is going to lay off a bunch of people. So if you have friends, if you're interested with hiring, we have a great team here. We have another great team in Prague. So we travel between the two offices. It's another perk. So feel free to say hi to us. Say hi to me, say hi to people that have Productboard. You met Jana and Sabrina at the entrance, both downstairs and upstairs. Go and say hi to them. They're our recruiters. And yeah, have fun today. Thank you.
Thank you. Yeah, cool. Again, yeah, I think it's a pretty amazing. Productboard is just an amazing case of growing on Rails, being successful on Rails. Folks, there are a few chairs there. Please don't be shy to pick a chair. Do we need more? What do you think? We might need more chairs. I think Marlon will help us with that. Yeah, thank you. So with that, we have. I know you're all cannot wait for Jason to talk to you about writing better tests, more tests that are easier to understand. This is the criteria. This is interesting. Let's talk about this. After that, we have Bart with Passkeys at how to like an intro to Passkeys at Rails applications, and then after the break, we have Cameron, who came up with something interesting with Ruby and Wasm, and then Alex with Bazel, which might be something new for all of us to learn today. So thank you so much. Again, we have an open mic. If you're here for the first time today, you're not familiar with this. It's when we all kind of share short announcements or questions or anything. And so this is my call for you to mentally prepare and prepare and share something during this open mic session. Now, Jason, come over and let's help you get set up.
Jason, I don't know if you want to speak up or do you want us to try to?
I can just speak up, it's fine.
Yeah. But you need to join Zoom. This is the tricky part. So you need to join Zoom and you need to connect to Wi-Fi. Folks, sorry, 30-second break. Productboard, guest, BB guest. Productboard, small letters, 2020. Wait a sec. Turn down, turn down.
Okay.
And now I'm sharing the slides
Okay.
like this.
And then should I just do entire screen?
No, just do this.
I'll do this, okay?
Share, and then click like.
Okay,
Do you want the clicker?
that would be nice. Thank you.
I'm gonna ask you. See,
Mm-hmm.
no, okay, continue. Maybe not, maybe. Continue.
Oh, sorry.
Okay, let's try. No, it doesn't work. Okay, sorry. Let's.
I'll just do it
yeah.
manually. Yeah.
We're set up. So, folks, how many of you listened to one of Jason's podcasts? Yeah, a lot. Quite a lot. So, Jason is hosting a Sin City Ruby conference.
Raise your hand if you're speaking at Sin City Ruby.
This year it's going to be in April. When is it?
11th and 12th.
11th and 12th in Vegas. Yes. And Jason is the author of Professional Rails Testing Book.
Vito, could you hold that up for me?
Thank you. It's the first time I'm seeing it in physical form.
Highly recommend it.
Highly recommend it. And also the what else? What else? So many things. Snail mail.
Yeah, I have a snail mail newsletter and I brought a bunch of copies to give out. I'll be talking about that during the talk, but it's called Nonsense Monthly.
So with that, please welcome Jason Swett.
Okay. This talk is about how to write tests that are understandable. What is the biggest problem with most of the test suites that we work with? Let's have a little audience participation. Cameron. Yeah.
Flaky.
Flaky, okay.
Slow. They do exist, but flaky.
They do exist, but they're flaky. Okay, slow. Uh-huh. Don't make sense. That's a big one.
Don't test anything.
Yeah. Okay, so we've heard they're annoying. Is that what you said? Yeah, so there's a problem. Speed, flakiness, lack of coverage, over mocking. I contend that the biggest problem with most of the test suites that I see is that you can't tell what the fuck is going on. Okay, so we're going to talk about that. First, a little bit about me. I guess Irina already introduced me. I didn't know she was going to do that. Author of Professional Rails Testing, host of the Code with Jason podcast, and I work as a consultant, and I'll talk more about that later. But I do consulting on topics, including what I'm going to talk about today. So why are our tests so hard to understand? Does anybody have any idea why this is? Why does this happen? Skill issue? Okay. I think
in order to answer that question, we need to go a little bit deeper and ask ourselves some more fundamental questions. Like, what is application code and what are tests? Might seem like a funny question to ask, like, what are tests? We all know what tests are, but can you put it into words? What is a test? Can anybody say what a test is? Yeah.
A/B testing, something like that.
Okay. That's one kind of test. A/B testing. Yeah. Go ahead.
Definition of functionality.
Definition of functionality. Okay, and yeah.
Specification.
Specifications. All right, I wasn't expecting the correct answer so soon. But yeah, a test, the way I word it is a test is an executable specification. Took me many years from when I started testing to when I realized that a test is an executable specification, and I started putting it in those terms. Okay, so that's what a test is, and we can talk more about that, but let's also talk about what is application code. So we have the test code and we have the application code. What is code?
The executable implementation of the specification.
The executable implementation of the specification. That's pretty good. Oh, a process that humans want to repeat over and over again by machine. Yeah, can you say yours again?
Me?
Yeah.
An executable implementation of specification.
An executable implementation of the specification. Yeah, that's interesting. And Brad, what did you say?
Just a human process, or a process that humans want to have a machine repeat over and over.
Yeah, a process that humans want to repeat by machine over and over. Yeah, so okay, so the conclusion that I arrived at is that code is machinery. Application code is machinery that creates a product. And so I mean product like in the really broad sense of the word, like if an endpoint returns an HTTP response, for example, that is the product that the code generates. And not to get too like wacky, but I realized after I thought about it that like it's not just an analogy, like code literally is physical machinery and it literally creates a physical product. Like code exists on a disk, like that's physical. So the code, even though we see it on the screen, it is a physical entity, but we don't need to talk about that part. So application code is machinery that creates a product, and tests are executable specifications for that machinery. And you could flip that the other way also and say tests are executable specifications. And what was your definition again?
Now I can't. For which one?
For code, for the application code.
Executable implementation of the specification.
Yes.
Yeah. So I wasn't expecting such a thought-provoking answer. So now I'm gonna go have to like sit in my hotel room and ponder that.
I have a talk that I've been working on. The idea that you can write code without tests, but you can't write code without specification. And I actually checked with the guy who created RSpec and confirmed.
Stephen Baker.
RSpec stands for Ruby specification.
Yeah, all right, so brief aside, I'll repeat some of that in case anybody didn't hear. So you talked with Stephen R. Baker, the creator of RSpec, and he actually told me the same thing because I talked to him the other day, and he said RSpec stands for Ruby specification, and that makes so much sense. He also told me that he doesn't use RSpec, the creator of RSpec doesn't use RSpec because it was never intended to be used. So we're all doing it wrong. Right. So I would like to attempt to persuade you, if you're not already of this state of mind, that in a system that has tests and application code, the tests are the main thing and the application code is secondary. Because the application code is subordinate to the test. It answers to the tests. The tests only answer to your arbitrary desires, which is not the way that most people think about it. It's not the way that I thought about it for most of my programming career. But after I worked with one of my consulting clients for a while, for example, he's like, I used to think of the application code as being the main thing and the test as being something secondary. But now I think of the tests as the main thing. And I want to, hopefully you buy this statement also. If your tests are fucked, then your application code is fucked too. I think that is necessarily true. I'll also say, people usually find this statement extremely controversial or so self-evident that it's not even worth stating, that you can't have good code without tests. Does anybody not buy that? Everybody buys that? Sorry?
Everyone claims.
Everyone claims to. Okay.
I work with people who will have a problem with that statement.
Yeah.
I buy it, and I actually have interesting conversations with. It's interesting how some people approach development in a completely different way than I ever could imagine. For example, using dropping a debugger and poking around and developing your code as you are in the debugger.
Okay.
And then taking what you did in. So in a sense, you are kind of testing your code as you're developing it, but not.
Yeah.
Specification beforehand.
Right. Yeah, I mean, all code gets tested one way or another. Yeah. Okay, so everybody here, nobody raised their hand that they don't buy that statement. I don't believe everybody. Yeah.
I just feel it's a test for a signal of maturity of the code base.
Mm-hmm.
So if I'm prototyping something, my feedback loop is going to be for my end user. It's not going to be for the test.
Mm-hmm.
So if you want to drive velocity, unfortunately, I've not written a test because I'm like, I don't know if this is going to be a strong signal of our customers and not spend too much time on test suite. But I actually don't like tests, so that's where I come from.
Interesting.
I've never been in a test suite where maintaining it was worth it.
Can you please leave? Okay. So for any silent dissenters in the audience, and in case you, dear viewer, don't buy my statement, I have a rock solid thing to share with you. Okay, so my rock solid premise number one is you can't have good code without periodic, non-trivial refactoring. I think that's pretty hard to argue against. And my second premise is that you can't do non-trivial refactoring without tests. And so if you buy both of those premises, then what necessarily logically follows is that you can't have good code without tests. So if you disagree with me, you're just wrong. Okay. So if we want to have understandable tests, there's a lot that goes into that. But again, first we need to go down to the very fundamentals, and we need to understand what tests are and what they're for. So we've discussed it a little bit already, but what is a test?
Specification.
Yes.
That's executable.
Yes. And what are tests for? What's the purpose of tests?
Proof.
Proof? Wait, was that you who said that? The test? Okay. That was you, okay. 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 Does anybody have any additional answers?
Documentation.
Documentation? Foot gun prevention. Okay. Defect prevention. Yeah, protecting against regressions is maybe,
Yeah, shipping bugs to production.
yeah, okay.
Reduce that number.
Okay, so here's what I came up with, which I think is consistent with all that. Okay, so I think that a test has two purposes. One is to describe the behavior of a system. So you said documentation. I think this is basically a different way of saying the same thing. So it's like there's two audiences for a test. One is the human reader, and the other is the system. So a test exists to describe the behavior of a system and to enforce the described behavior. And Bob Martin said this really interesting thing. Tests are about specification, not verification. And this is a really subtle, but also really important distinction. In fact, the first sentence of the first chapter of my book talks about the difference between specification and verification. And I say that if you get nothing else out of the book, that distinction between specification and verification is the one thing that I hope you get out of it. Unfortunately, it's a really hard thing to get across. And we'll talk a bit more about this concept as we go via some examples. What makes, I'm gonna go back for a second. What makes a test understandable? I'm gonna pause for a second because I feel like we've been going a little too fast for a second. Okay, I'm caught up. What makes a test understandable? Yeah.
It has a clear mapping to the implementation.
A clear mapping to the implementation. What do you mean by that?
Yeah, it's not like convoluted. You can just look like, oh, this specification, the first name needs to be uppercase. So you should be able to look at the same file and see it's right there and find, you should be able to find the specification very easily next to the implementation and not have to dig around for it.
Yeah. This is hard to articulate. It's like the test should be a good explanation of the behavior that it describes, but it's hard to talk about it without being kind of circular.
Yeah, I think it's just the two need to be you need to look at both and see them ideally in the same, close to each other, so you can intuit what's going on.
Yes.
You can intuit the implementation and specification.
So, okay, I'm going to go to my answers to this question. Does anybody have anything to add before we go to the next slide? Yeah, Fido.
I think it needs to tests are more understandable when they're more concrete and simple.
Yeah. Okay. So Fido said something really important. Tests are easier to understand when they're concrete. Okay. And I'm going to say something now about specification versus verification. I used an analogy in the book that I don't completely love, but it's the least worst analogy I've come up with so far. Let's say you're visiting a squirt gun factory, and you want to make assertions about the design of the machinery that manufactures the squirt guns. One thing you can do is you can have a verification mindset, and you can go to the factory line and pick up a finished squirt gun and ask, does this squirt gun work? And you can test that squirt gun and say, does this particular squirt gun that I'm holding in my hand work? Or you can do the same exact thing, grab a squirt gun, but ask, is the squirt gun manufacturing machinery working as specified? And even though you're using the same object, in the second scenario, you're only using the squirt gun as a proxy to make assertions about the machinery. So the difference is about your target that you have in mind when you're performing the tests. This is why it's like a subtle, difficult thing to get across. But it's, again, the target that you have in mind. Okay. So I think what makes a test understandable is, first of all, if you're expressing it in terms of specification rather than verification. It's easier to understand if it's meaningful. And what I mean by meaningful is if it targets ends rather than means. You guys have probably seen tests that assert for the presence of active record associations.
Okay.
Yeah.
Useless,
Useless. Thank you. Why is it useless?
because it's a configuration check. I can just look at the model and see it's there already.
It's like,
I believe Rails should work. I don't need to test that I'm using Rails correctly then.
you know, I don't even think that's a necessary part of the argument. Because it has nothing to do with believing that Rails
I went
should
too far.
work. But it's a common argument, so I think it's important to address that one. It's not about believing that Rails should work. If Rails were to not work, what would happen? The behavior that association enables would fail. So you don't even need to believe Rails is going to work or not, because again, if it doesn't work, then your higher level behavior will fail to work. And if you have a higher level test, then your test will fail. So when you have tests for associations, you're testing the means to an end, not the end itself. And it's redundant, because if you have a test for the behavior that association enables, then again, if that association were to break, then your higher level test would fail. So it's better to target ends rather than means. And ends tend to be at a higher level of abstraction and easier to understand, because it's like you test an association, for example, and it's like, okay, but like, what does that mean that this association, like, what does that give me? You don't know. But if you're testing the end feature, then it's like, oh, okay, this is, we need to be able to create a new customer record or something like that. I think tests are easier to understand when they're at the appropriate level of abstraction. And almost nobody ever does this. When you open up most tests, you're just presented with a giant wall of details. And the writer of the test is leaving it up to the reader to look at all the details and think about all the details and do the job of figuring out from the details what's the higher level meaning. And that is wasteful, because maybe you saved some time in writing the test, but now when people read it, it's going to incur a cost every time somebody has to read that test. And so it'll be much cheaper if you take the work to add a layer of abstraction over your test, so that you don't have to see a whole bunch of details and figure out the meaning. Instead, you can just see the meaning directly, and then you don't have to think as much. The fourth thing here is cohesion. What do you guys think I mean by cohesion in tests?
Similar styles.
Similar styles? That could apply. What else? What is cohesion anyway? Holding together. The way I define cohesion is grouping like with like. If you look at a file and everything in that file is about the same thing, then it has cohesion. I think Ken Beck said cohesion is when the same things in the file are tightly coupled with one another in a way that is appropriate for them to be tightly coupled. He worded it much more eloquently than that, but that was the idea. Okay. How am I doing on time? Verification. So here's an example of like a verification mindset versus a specification mindset. In the vast majority of the test suites I look at, the tests are expressed in this first way. It does X, it does Y correctly, it returns the right Z. it makes me extremely sad when I look at a test and it has the word correctly in it. Why do you think that makes me sad? Any ideas? Yeah.
That's kind of the definition of the task.
That's a good point. I didn't even think of that. In case anybody missed it, what Cameron said was, shouldn't the tests always be asserting correct behavior? It's kind of superfluous to say that it's correct. Yeah,
That's the question, what is correct?
exactly. So 10 minutes? Okay, I didn't mean to talk for so long. Correctly. Sorry, what did you say?
It asks the question, what does correct mean?
Yeah, when you look at a test and it says it does such and such correctly, it's like, okay, but what does correctly mean? So don't put the word correctly in your test. Instead, say what correctly means. What's so funny, Fido?
That I don't.
Okay.
I feel like I don't like this in terms of right.
So what I think is a better format for tests is like under scenario A, it does this. Under scenario B, it does this. And the other good effect of that is like, sometimes when you look at a test and it's like, it does this. It's like, okay, but like, what's the significance of that? But if you say in this scenario, it does this, and you show an alternate scenario or like the inverse scenario where it does this other thing, it's like, oh, okay, so like when this is the case, it does this, but in this other situation, it does this. You can piece together the meaning more easily when it's like that. Okay, we already talked about some of this stuff. I do want to share my definition of abstraction because I think abstraction is a really important idea. To me, it's the act of replacing lower level ideas with higher level ideas in order to make a particular aspect of the world easier to understand. Thank you. Based on our short time together, I value your opinion, so I appreciate your thumbs up.
Well,
And by the way, there's abstractions outside of programming, and I think we can think about those and learn from those, but we'll have to skip that for now. Cohesion is grouping like with like. Okay, so my talk is almost done. Here are kind of the things that I want to leave you with. In order to write tests that are easy to understand, again, I think it's really helpful to go down to the fundamentals and give yourself a firm foundation of what are these basic things. What is a test? What is application code? What's the purpose of a test? And I challenge you to put these things as concisely as you possibly can and commit the definitions to memory. Because I think, there's so many things in programming, like words we throw around all the time, test, abstraction, cohesion, blah, blah, blah. And if we can't recite the definition of these ideas off the top of our head, then I think it could be said that we don't understand them as well as we could. So I think it's a really good idea to do that exercise. And these 4 things that make tests easier to understand: specification rather than verification, meaningfulness, remember targeting ends, not means, abstraction, replacing lower level details with higher level ideas in order to make things easier to understand, and cohesion, grouping like with like. Okay, we already mentioned Sin City Ruby, but I want to tell you about it. It's either the 10th or 11th or the 11th and 12th. Someday I'll get it right, but it's on the website, sincityruby.com. The dates on the website are correct. 100 attendees maximum. It's a very small conference. It's very intimate. We spend 2 days together in Las Vegas. And we have some good speakers. Again, Irina and Fido are speaking there. Chris Oliver from Go Rails, if you know Chris. And I'm not going to read the whole list to you, but there's the rest of the speakers. Brief word about my consulting. To give a quick taste, one of the things that I often do is I'll work with a team and we will have maybe a weekly or even daily session where we talk about this kind of stuff. And I challenged the team with questions like, what is the point of testing? What is abstraction? All these kinds of things. Testing, OOP, project planning, just like all kinds of stuff. And we think about these things and how to be more efficient and productive and stuff like that. Again, my monthly snail mail programming newsletter can be found at nonsensemonthly.com, and I'm going to pass out some copies of this letter tonight. This is my book, Professional Rails Testing. I brought a whole bunch of copies with me, but they're in my hotel room. Are we going to like a drink place, a bar or something like that after? Maybe I'll go back and get them and give them to you. Yeah. And here's all that information in one place. And that concludes my talk.
All right. Thanks, Irina.
I have a clicker, but do you want?
I'll just use the keyboard. Yeah, so tonight I'm going to talk about passkey authentication in Ruby on Rails. I'll talk about very briefly what passkeys are, why or why not you might want to use them, and then how. And 20 minutes is not enough time to implement passkeys, so I might be going through the code very quickly. I'll share the slides and sample code. So just heads up. My name is Bart Agapinan. I'm a senior software engineer at IDMe. I'll start. We are a Ruby on Rails shop, and we are hiring. So this QR code is for our jobs board, if anyone's looking. I've been a Ruby on Rails developer since 2007, although really only seriously since 2015 when I started doing it professionally. So I love Ruby on Rails. This is my first SF Ruby meetup talk. So hope it goes on. Thanks. And a quick disclaimer, this is a security and passkeys talk. I am not a security and passkeys expert, just an enthusiast. So before you put any of this into production, check with your security team. So this is what I want to talk about in the brief amount of time. What are passkeys? What are the pros and cons? And then finally, how to add passkeys. And I'll have a little demo at the end. So what are passkeys? Also known as WebAuthn or web authentication. It's a World Wide Web Consortium standard for secure public key authentication for web apps, or websites, web apps. They claim to be more secure than passwords and one-time passwords because they can't be phished. They use strong cryptography, and they can be used for several ways to keep people out of accounts. But getting into your account, it can be used for two-factor authentication. It can be used for passwordless login, and it can even be used for usernameless login. So basically, nearly fully anonymous logins. But I'm not going to really talk too much about that. And then compared to existing security methods, these are some popular ones you may have seen: username and password, two-factor auth using authenticators, SMS, email, even phone calls. My bank does that. And then magic links, and then just kind of comparing to passkeys. 2FA is often phishable, so somebody could call you up and have a code sent to you and have it read over the phone. Many reasons that passkeys are better. And I won't go through all this whole list, but just take my word for it. So passkeys deal with public key cryptography. The private key never leaves your device. There's a little asterisk there that there are cases where it does, but in a hopefully safe way. It requires an authorization gesture is what the standard calls it, where the user has to opt into using it. You can't write a passkey on a Post-it and stick it on your monitor. So it's already going to be more secure for some people. So obviously sounds like you should use them, right? Unfortunately, there's been a lot of press recently about how passkeys aren't all that great. So it depends. Passkeys, it means you need to make a choice between usability and security. Talk to your local staff engineer. So here are some recent articles you may have seen. These are just in the past few months. And of course, DHH himself wrote a blog post about how passkeys maybe aren't the best. So I'm at a Ruby meetup, Ruby on Rails meetup, talking about passkeys. Hope this works out. So actually, I don't know how important it is to talk about this, but there are two types of passkeys of authenticators. There's a platform authenticator and a roaming authenticator. Platform authenticator is something like 1Password or your Apple keychain. Roaming authenticator is like a YubiKey. Your users are probably not going to know the difference, or that these are even both passkeys. And so that can add some confusion that you need to know when you're implementing this. Make sure that you're not going to lock your users out, or that people will be able to use it when they expect to be able to use it. I won't be able to go into too much detail on that, but all those articles that I just posted go into that in some detail. So I'll share links to those if you're interested. Because things like this can happen. You can lose your YubiKey. You can set up a passkey on one OS and then try to use it on another, and you may not be able to use it depending on what kind of key you set it up with. You might delete your passkey, or through no fault of your own. Maybe it just disappears somehow. That happened to some people. And if that happens, you may not be able to access your account. You need a fallback. And so that's where the convenience versus security trade-offs have to be made. So these are my non-expert recommendations. If you want to use passkeys for MFA, you should probably have at least 2 forms of MFA, either 2 passkeys or passkeys and an authenticator, or another 2-factor setup. Or you're going to need to have a customer service rep who can go and reset this stuff. So that can be a cost. For passwordless login, you probably want to also have a password in case it doesn't work. And then for usernameless login, like I said, I wasn't going to talk about this, but there maybe are cases where it's okay to use it. You don't care about the data so much, or you have another way of doing account recovery. So when you're deciding whether to use passkeys, just make sure you balance your user friendliness, because these are pretty user friendly if used correctly, with security. Because making it more user friendly can actually make your security go. All the security gains you made by using passkeys can go away to make it user friendly and recoverable. And I'm not going to read this whole list, but there's lots of things to consider. Despite that, I'm still going to tell you how to add passkeys to Rails. And maybe actually before I show you that, I'll just do the demo, because I think this will make more sense when you see how it works. So I have written a small demo app.
Yeah.
All right.
Yeah, you're sure.
Yeah. So the way this works is it's just a sign-in and a user settings page. So I have one account on here. And you'll notice I just have a username here, not a password form. So this is a little different. But what that, oh shoot. Haha. Of course. Hold on a second. Got to run the server. Yes, this is actual running code right here. All right, let's try this again. Yeah. And of course, I'm running it on a non-standard port. Nope. Okay. All right, never mind. The server is crashing. I ran it in dev containers, but now I'm not running dev.
What did the demo do?
Okay, the demo, well, I'll keep going through here. So the demo basically let you add passkeys to your account. It showed you the UI for adding passkeys, and then logged in with passkeys with passwordless login. Maybe I'll be able to get it working at the end. So I have a sample app. This is the URL. You can go check it out. I'll also have a QR code at the end. This works with any recent version of Rails. This setup example will be with JavaScript using import maps, stimulus, and in this case, it was just the Rails generate authentication setup. So it works with that. So it has two main dependencies, a gem called WebAuthn and a JavaScript package called WebAuthn.json. And so this is how you add them. And then you'll need to add a passkey model and connect it to your user. So a user can have many passkeys. And then this last piece is adding a passkey ID to your user model. That's actually optional. There's other ways to do it, but all of the online examples that I found use that, and it just makes it a little easier. So this is the flow. When you're creating a passkey for a user, you create on your server, you create a challenge. You send that challenge to the browser, excuse me. The browser makes an API call, or the JavaScript makes a call to your browser to say, click your authenticator or click the button to create a passkey. The authenticator will create a key pair at that point, and it'll be tied to the domain of the site that's setting up the passkey. And it will take the challenge that the server sends, and it will sign it using its private key and send it back to the server. And the server just verifies that the public key that is sent with this challenge and the signed challenge match. And if they do, then they say, okay, good, this authenticator matches, or the authenticator has the private key that I think it does. And then it saves that passkey to the user. That's a kind of a simplified way of what it's doing, but generally speaking, that's how it works. So in order to do that, you have to add a passkeys controller. This is the code to do that, and then some routes. You need to have a challenge route, and then there's the normal create and destroy. So I'm not going to read through everything here, but the important stuff is you have a form that posts to your challenge URL. There's some stimulus controllers here that are going to kind of take the data that comes back from that and process it a little bit more, and then send it to a third URL. And I'll show you the stimulus code for that. So this form just has a nickname for the authenticator. So that's just so the user knows, they can give a name like, oh, I'm using my YubiKey, or I'm using 1Password. They know which one has been set up in case they ever want to delete it. This is the challenge code in the controller. So this, again, you don't need to look at everything, but this calls the WebAuthn library. It generates a user ID that's unique, and it generates options that are going to be sent to the JavaScript front end. And that's how the authenticator knows who this is for, what user this is for, and what domain. And then you can see that it excludes, it has this exclude clause there, which basically says, don't include any passkeys that are already associated with the user. And then it stores it in the session so that it can compare it later. This is the JavaScript. This is a snippet of the JavaScript where it calls that WebAuthn.json create. That call is what tells the browser to ask for the user to tap their key. And then it posts that to the callback URL, which is also on which is the create endpoint on the passkey controller, sending the payload that the authenticator sent to it. And then finally, so this is the endpoint that collects it. It takes that that payload, it feeds it to the WebAuthn credential from create method, and then it compares what it got with what's in the session. So it tries to pull, it creates a new passkey on the user with the data that came back, and then it verifies that or this passkey credential that verifies, where it checks that the challenge that it sent matches the data that came back from the authenticator, and then it saves it. And then to log in, so that was it for that. Once it saves the passkey, that passkey is now associated with that user in your system. To log in, it's a very similar process. You create a challenge. In this case, it's for authentication. The authenticator already has the same private key that's tied to the domain that you're trying to authenticate to, and sends back, basically signs that challenge and sends it back, and then your system will verify that the challenge matches one of the stored passkeys, and because it can be any of the passkeys that were sent before. So in this case, you probably already have a session controller if you're using Devise, or if you use the Rails authentication, creates a session controller. You need to add these two endpoints, challenge and verify. In your URL, you add a button to, and now I'm kind of glossing over the UI changes. There's a lot you might have to do to actually add the, sign in with passkey, that collection of the username first, whether you're going to do passwordless or whether you're going to do MFA or even usernameless. Those are all kind of UI decisions. This example is for, this could be used for either 2FA or passwordless. So this is just a button that's going to submit to, that's going to post to this challenge URL. It's going to send an email address that was previously entered. And then there's going to be a login stimulus controller that's going to intercept the data and then send it to the verify URL. So this is what the challenge looks like. You just, assuming that you've typed in an email address already, it's going to load that user. It's going to create a WebAuthn credential. It's going to say, and this is a choice for you, but in this case, this says any of the user's passkeys are good for logging in here. You can, if you wanted to like restrict it to a YubiKey or restrict it to a certain passkey, you could do that. Again, you store the passkey challenge into your session so you can compare it later. And then we'll scroll up. This is later on in the same method. So you store the challenge in the session, and then you're going to send back those that challenge to the front end. This login controller is going to intercept that. It's going to call that WebJSON in the WebAuthn JSON before it called create. In this case, it's calling get, and get just means tell the user that I want them to tap their key, and then it will send that data as JSON to the callback endpoint. That's the verify endpoint, verify action. This will create a credential from the parameters that were sent by the authenticator. It's going to load the user from the session, and then it's going to check all of the passkeys that the user has. Do any of them match the ID of this credential that was just sent back? And then this verify call is where it checks if they match. And if it does, then it will update and log the user in. And what's not shown here, I guess you can kind of see it on the bottom. Any of these steps fail, it just raises an exception. So your exception handling is how you handle failed authentications. And at the end, you also have to make sure you clear your session. I tried the demo already. I don't think it's going to work if I try again. Because I'm missing, actually, you know what? I'm just going to try one more time. I'm going to try it with my dev container. So let's try this one more time. Can I close it? No. Go down. I'm going to start this up in a known good environment. All right. Okay, hopefully this works. So, dev containers for the win. So I'm going to sign in with a user that only has a username and password and not any no passkeys associated with. So when there's no passkeys, this UI shows a password field. I have a very secure password that Chrome is going to tell me is not secure. So this is my user. I have no passkeys associated with it, and I'm going to just add one. I'm going to add one password. Hopefully it's set up. And so, yeah, so you can see it. I've got an offer to save a passkey, so I'm just going to do it. It's saved, and then you can see here now I have, oh, I spelled one password wrong, but so that was the nickname that I gave to this one, and I just added this as a as an example, but this is the type that the authenticator returned. It says this is a platform authenticator, and then I'll add a YubiKey just for fun. Let's put this in. And then in order to do this, and this is one of the things that's a little confusing, for 1Password, you have to click this, and then you get another one. And I think here you can just hit the key. It doesn't say you can, but that's how it works. So you can see this is a cross-platform passkey. So it's a little different. But now my account has passkeys, so I can log in with it. And 1Password is nice and helpful here. And in this case, now it says sign in with passkey, it doesn't have the password anymore. And now that WebAuthn get was called, and now I can just click the sign in button and I'm in. And that works both with 1Password and with a physical key. Yeah. And that's it. Did you have a question?
Yeah. If you didn't have 1Password browser add-on on your operating system on the browser, like, would this not work? Is the private public key signing process something that's native to Chrome?
So Chrome has a built-in passkey implementation, I believe. Apple has one built in, so Safari can do it. I'm not sure. I think Android has one, but I'm not sure about like Firefox if there's a native one. But there are lots of like 1Password is not the Bitwarden will do it, I believe, and some other password.
Which one? Let me see.
Yeah. This is one of the problems with passkeys is like not everybody knows what's going to work and what browser it's going to work on, and it's not standardized yet, so it may get better.
Next question. Even in one browser, sometimes the site will say I have passkeys and it'll use Touch ID, which is great. And then other times it throws up this QR code, which is like, no.
Yeah.
So like what technically is going on in the implementation of the server that's doing that? Like why is there that difference in the same browser?
So I think that's not a server thing. I think that's a browser thing. And in some cases, like you saw, 1Password wants to be the authenticator but it allows you to fall back to using another one. Sometimes I've had the Apple one will jump in front and I can't use 1Password because it got there first. So it seems like they don't play nicely. And that's part of what the problem is. Ken?
Does Rodionov handle this natively?
I don't know.
It does, I use it.
Oh, okay.
Yeah.
Yes.
That's what I thought.
Yeah, so none of this code this didn't use any like special software, it didn't use devise, it just used that WebAuth and gem. But yeah, if Rodionov has their own implementation, then this demo does not apply, but the way it works should be the same. Yeah.
I think you mentioned you could use Passkeys for anonymous sign-in, but in the demo you were looking at by user ID. How do you find the right passkey when you're doing anonymous? Do these passkeys have IDs or something?
Yeah, so every passkey has a unique ID. So that
So you
that
don't
would be
have
how
to
you.
check every user's passkey then.
If you were doing usernameless login, then the passkey would be basically sending you the user ID along with
Got it.
its the answer to the challenge. So
Okay, cool.
yeah. I think that was it. So this is a link to the demo app that I just was running. There's also, these slides are linked from that GitHub page. And yeah, thank you so much.
Repeat speaker as a Ceph Ruby, which is the main credential. Also, a container of new component.
Which apparently sucks.
And the
Second best, nice. Thank you.
and the employee of GitHub. That's what we got from you.
Yes.
Shouting
the shirt.
the company name. Yeah.
For sure, for sure. Well, so I was gonna do a really quick open mic thing, but two people mentioned React, and so now I feel like I shouldn't say this, but I think it's funny. This is a very important website that I found. It says, should I use React for that? And it just says, no. So we have our answer. All right, so yeah. Let's see, let me make sure I have my speaker notes and whatnot. I need to do the full or the, I mean, I guess that might not be possible with Zoom, huh? That's fine, we'll just make it work.
We have speaker notes for the meetup.
I mean, I just want to be able to see the next slide. It's fine. Okay, so I'm going to be talking today about using Wasm, a Wasm compiled module from Ruby, and I'll explain why you might want to do that, or maybe not. The first thing, though, that I want to say is that I know that Productboard has offices in Prague, right? And I wondered if people from Prague are called programmers and they do programming. Oh, thank you. Programmer, is that a thing? I feel like that might be a thing. No? Okay, well. Also, my code that I'm going to present has no tests. And I think that that's probably, Jason, I think probably thinks that it's fucked by definition. And so you might not want to listen to this. I don't know, it's up to you. All right. Just a spike, exactly, yes. I'm Cameron Dutro, I work for GitHub. Here's my social links. And our goal today is going to be to compile a C library into a Wasm module. And then we're going to call those C functions from Ruby. And hopefully at the end, we'll have learned how Wasm works. This is the whole reason that I am giving this talk, is I learned a bunch about how Wasm works, and I wanted to share that with somebody else. And so that's why this talk exists. So what C library are we going to be using? So Onigmo, who knows what Onigmo is? Nobody knows. Okay, that's fine. Somebody raise it. No. Onigmo is Ruby's regular expression engine. It's actually a separate project. You can find it on GitHub under K Takada's username. It's used by other projects too. I want to say Python uses it as well. And it's built into Ruby. So most of the time you wouldn't actually, I mean, all the time, you would just use Ruby's regex engine. You wouldn't have to reach for this. We're using it because it is a non-trivial code base, right? So it does something cool and useful. I mean, everybody uses regexes kind of whether they want to or not. And it's because of that, it's like a decent Wasm showcase. So I talked about why I'm giving this talk. I learned some things about Wasm and how to use it from Ruby. Why did that happen? Well, it happened because in 2022 or so, I started working on Garnet.js, and I talked about that at this meetup before. There's a URL for it. It's an implementation of the Ruby virtual machine in TypeScript. The idea was that it could be run in the browser. And it's a Ruby implementation. Turns out that's really hard. So I haven't actually contributed to it for a little bit. But back in the day, I needed to bolt on a regular expression engine because Ruby has one. And so Garnet needed one. And I didn't want to write one because I'm just not smart enough to write a regex engine. And so I also didn't want to use JavaScript, which also has a regex engine, because it's not 100% compatible with Ruby. So if I were to run, the Ruby test suite, it would fail likely on some of those tests. It's not the same thing. But I learned yes, that's right. There were tests in that one. So that was not terrible code, as it turns out. But I could compile Enigmo to a Wasm module and then use that in the browser. And that's why this whole sort of talk came about. It's because I originally wrote the code that you're about to see in TypeScript and then ported it to Ruby for this talk to sort of showcase how it works. It works very similarly in both languages. So what is Wasm? And we've heard about it, I think, a couple times at this meetup. It stands for Web Assembly, WASM. It's a 32-bit binary format, so it's not 64-bit, which is super interesting. At least I thought it was. So all processors these days are 64-bit. It's executed by a virtual machine, just like Ruby code. The cool thing about it, though, is that it's embedded in the browser, or at least it can be. Most browsers support this now. It's stack-based, like Ruby is. It works on this linear memory model, so there's just a giant chunk of memory that's like all contiguous, and you can read and write from that, unlike what an operating system would do in most cases, which is to like fragment memory all over the place. And it also, even though it's a virtual machine, it has pretty decent performance. So that's why there are whole websites built with Wasm. So if you're familiar with Figma, Figma is actually built in C++, compiled to Wasm, then runs in your browser. There's also a bunch of different like implementations and runtimes of Wasm. Wasmer is a popular one. The one that I'm going to talk about today is called Wasm Time. It has bindings to Ruby. Wasm 3, Wasm, Tiny Wasm is an embedded version. A lot of different implementations. So why would you use Wasm? Well, it sort of offers the same benefits that Java was supposed to offer, right? So it can compile it once, you can run it anywhere. It's got applications sort of, everywhere you can imagine, desktop, mobile, embedded systems via Tiny Wasm, other things like that. And of course, web browsers. That's one of the big sort of reasons that I'm excited about Wasm is if you run code written in other languages in your browser. And that's, I think, we're just talking about StackBlitz. StackBlitz does this a lot, it's my understanding. Very cool. So many languages compile to Wasm, C and C++ sort of being two of maybe the most, I don't want to say exciting, two of the most sort of common ones that you might compile to Wasm. So like people have gotten Postgres running in their browsers, they've gotten FFmpeg running in their browser, right? All because it's all written in C, you can compile it to Wasm, run in your browser. But also Go and Rust and Zig and even some of the .NET languages compile to Wasm, Lua, and even TypeScript via this other project called AssemblyScript. Yep, and I put him on there because, poor Java really tried to make the whole compile once, run everywhere thing happen. So I thought Duke deserved a little bit of a shout out there. Why not FFI? Why don't we just use FFI to talk to C libraries? Well, you can. FFI stands for Foreign Function Interface. And the idea is that it's a lot of the gems that you know and love in the Ruby ecosystem wrap C libraries in FFI and make calls to these C functions. And this is mostly enabled because Ruby itself is a C program, so it can run code as well, like link against code in C and call those functions. But in order to make this work, you need a C compiler. If you've ever had to like install gems for a Rails app and it installs Nokogiri and it's like building gem native extensions, right? Like it's having to compile libxml behind the scenes for you. And to do that, it needs to have a C compiler. It needs to have, that code needs to be, written to work on your architecture. And most of the time it works. Sometimes it doesn't, though, right? You have a lot of issues with this. At least I have in the past, like, it's potentially slow and notoriously error prone. Sometimes you get these compiler errors that make no sense. I think somebody joined and is talking. That's fine. Tanya LV. Hello, Tanya. It's all good. And also you have this issue where like binary, so you could provide, like precompiled binaries for libxml and for Nokogiri, and that's certainly been done before. But that also means you have to maintain that then. So like every time that Flavor Jones, right, releases a new version of XML or of Nokogiri, he has to make sure that he also provides these binaries for each platform that somebody might be using, Darwin, macOS, right, Linux, Windows, all of those. And you might not have access to a machine that can do that. Maybe you have a CI system that can do that, but those cost money, right? So the idea being that like having a binary per architecture and per OS can be really hard and difficult to maintain, right? Wasm binaries, on the other hand, are portable. You compile them once, you can pass them around, they'll run on any system as long as you have a Wasm virtual machine to run them on, right? So it's the same idea of Java. Java has a virtual machine installed on Mac or on Windows. You just download that and install it, and then you can run your Java code. Same thing with Wasm. One of the big differences, of course, being that Wasm can run, again, in your browser. So let's look at, this is directly taken from the Onigmo repository's examples folder. So it's a little bit of C code, and the only reason we're looking at C code is to understand the shape of how this library works. So we have a regular expression object, onig regex, it's a pointer, it's the memory address. We have a pattern here. Don't worry too much about all of the very like complicated like syntax of C here, but the idea is we have a pattern, we have a string that we want to match with that pattern. We call this onig new function, pass in some parameters to it, and that because we're passing a lot of the stuff by reference, this is initializing that regular expression and compiling this pattern that we're passing in. And then to do a match, we create a new region. We have some pointers to the string in here, and we pass those into this function called onig search. And that returns to us an int. And that int can be less than 0. If it's less than 0, that means an error condition. If it's greater than or equal to 0, that means a normal exit. And so we can say, okay, it also gives me the index at which the match occurred. So I can print fprintf means puts this to the screen, matched at position R, right? Now, and we can also loop through all of the region information that was captured here. So there might be multiple matches, right? There's one sort of beginning match for the whole thing, for the whole match. And there's different regions within that if there are capture groups, which there are in this case. And you can loop through those with this numregs in this region object. Now, if it didn't work, then we could also print out an error message. And then at the end, because this is C, we have to clean up after ourselves, free the region and free the regular expression. Okay, so the general shape of this is we have a pattern in a string, we call onig new, get a region with onig new, region new, and then onig search, and then we're done. So if we were to imagine a Ruby API for this, let's actually maybe say we do write a test for this. We're going to do the same thing, right? We have a regex object, onig regex, dot compile, and match against a string, and then we assert that what it returned to us is the correct information. We got captures and begin and end and match, things like that. So the idea would be that at the end of this talk, we could run this test and it would pass. So which functions do we need from Onigmo? We need onig new, and actually we're going to use onig new deluxe because why not? Onig region new, a bunch of them, and then also at the bottom, malloc and free, and we'll talk about malloc and free in a minute. Those are libc functions that we need to use. We also need a couple of constants. So Onigmo is really nice about giving us all this cool encoding support. So we're just going to use UTF-16 because that's what JavaScript used. That's what this is ported from. We also need onig ASCII or encoding ASCII, which is for the error messages that it returns to us. And then we're also going to do this casefold flag, not important what that is. And syntax Ruby is just the flavor of Onigmo's, the flavor of regex that we're going to use with it is the Ruby flavor. So how do we compile Onigmo to Wasm? Well, it's not that hard. I have to say I really struggled with this because I'm not a C programmer. I have not used the C tool chain that much. But trying to get this to work, there's a bunch of sort of prior art we're cobbled together and figure this out. So first thing we need to do is install the SDK, a couple of other tools. And then we're going to use Clang or CLang to compile using target WASM32 WASI. WASI, by the way, stands for the WebAssembly System Interface, and it's the thing that lets you talk to I/O. So you can read files, talk to standard in and standard out using WASI. We're going to link, so after we compile a bunch of object files, we'll link them together with Wasm LD, and then we can trim off some of the extra stuff using a couple of strip tools. And we can do all of this in a Docker container for portability. Okay, so here's the clang command, and there's just some highlights here. Don't need to commit this whole thing to memory. This is the build target I mentioned before. So instead of saying target equals like x86 64 Linux or something, you're saying wasm32 WASI. This is the sysroot. This is where we find libc. The optimization level, we're saying I want to build against libc. This thing should have libc built into it, like it needs these functions to operate that libc provides. A bunch of include paths. So, we're providing it a path to the current directory, a path to the wasm directory, which is where, actually, I'm not sure why that's in there. I'll have to think about that later. Encoding directories in this directory, which is where all the encoding support is. Here's all of the C files that we want to compile. So once we run this code, this command rather, we should get a bunch of object files, .o files, which correspond to each of the C files, and they contain object code, right? Like we've compiled these things into object code. They're not executable yet, or even a library. They're just object files. And then we run as wasm ld, and this is super important. So this is the linking step. And what we're saying is we want to be able to access these exports in our Ruby code. So we need to tell the linker to export them so we can use them. We also we don't have a main function. This is just a library. We're going to output a file called onigma.wasm. It's the linked compiled final version. And here's our search path again, so we can link against libc. Here we are linking against libc. And finally, we're saying like we want to link all of these object files together. So just star.o, these files. Okay, so once that's done, and then we run our strip command. So just take out some of the extra stuff we don't need in there. So by the end of this process, we've got onigma.wasm, and we can see that if we run wasm object dump, we can see all of the exports that are in this thing. So we've got our memory, which is the thing we're going to read and write to and read from. We have these constants that we needed, like the UTF encoding one and the syntax Ruby one. We have malloc and free and onig free and all this cool stuff. I cut it off because there's too much here, but all the functions that we talked about on the previous slide, those are now exported. We can use them. Okay. So now we get to actually write some Ruby code. And to do that, we're going to bring in the wasm time gem. And wasm time is a runtime for wasm that has Ruby bindings. So it's essentially a native extension that is written in Rust. And the nice thing about Rust is it's a lot easier to compile than C, at least in my experience. And it also includes precompiled binaries for a bunch of platforms, including my ARM Mac OS machine. And it allows us to call wasm functions from Ruby, and we can also call Ruby functions from wasm. So it's kind of the key that sort of unlocks all of the wasm goodness that we're going to do in a minute. So let's start writing some Ruby code. We require wasm time. We've got our module, Enigmo. And to sort of instantiate our wasm module, we've got an instance class method here. It's confusing, an instance class method. It's a class method called instance. Anyway. And in this thing, we're going to make a new instance of the wasm time engine, get the path to our module, the store thing, not important what that is. And then we're going to say instance.new here and pass in our module. The third argument, by the way, here is to pass imports. So you can pass like Ruby functions that then can be called from C code, essentially. Those can also be passed in this array at the end here. And then that's what we're going to return from this. We memoize it. And that's the start of our code. We're just going to be like essentially just like making this, have this little function that gives us a thing that now we can use to make calls to these functions. We're also going to grab these exports. So wasm time has this nice interface. We can say like .export. And then in this case, because it's a global constant, there's a toGlobal method, .get. So we're getting a reference to this thing. We also expose an instance or a method for our memory object that we're going to use to read to and write from, and write to. We'll see how that works in a minute. Okay, so now we're ready to do the first step of our process, which is the new function, so onig new deluxe. So to do this, we're going to add a method called onig new deluxe, and we're grabbing, using our exports again, we're grabbing that function. This time, instead of saying toGlobal, we're saying toFunc. This is a function we want to call. And then all we're doing is taking the arguments we're passed, and we're just forwarding them on to the onigma new deluxe function. So it's a really simple way of calling it. Now, there's a lot of sort of things we're not doing yet. We haven't actually like determined what we have to actually pass in here. All we're doing is giving it like an entry point. Like you call this thing, the C library will do something and hand you something back. And we also need to do this for malloc and free because we also need to be able to allocate and deallocate memory. And so let's just add a little handy function that lets us declare these functions more easily. So now we can say exports func, onig new deluxe, malloc and free. So let's take a look at the C declaration. This is in the header file for Onigmo. This is the onig new deluxe function. You can see it takes 5 parameters. So it also references this thing called an onig uchar. That's just a type def or an alias or an unsigned char. So nothing fancy going on there. Onig compile info is another struct, and this thing has a bunch of information about like how it should compile your regular expression. And then another thing, onig error info. So if an error happens, this struct will get populated with the error information. And we also need to pass one of these things in, and so we can see that it has 3 fields, all of which are also pretty standard. Or I would say we know what they are. Okay, so let's try to implement this. So module Enigma, we're going to do compile info first. We have our class here, and we'll say size 24. That's because that struct that we looked at a minute ago has 24 bytes of information in it. Because remember, Wasm is a 32-bit format. So we can, let's just bring up our definition of that struct here, and we can just count these fields and find out how many bytes they take. So an int is 4 bytes. Onig encodings are 4 bytes. Those are just addresses or pointers to data structures, right? So those are all pointers are also just ints really. And so that's 4 bytes there, and all the way down the line until we add those together and we get 24 bytes. Whoops. Okay, so we know that compile info struct is 24 bytes. So let's create a new instance of this struct. So we'll expose a method called create here on compile info, and it's expecting you to pass it a Ruby hash. And then in this guy, we're going to say, okay, Wasm, give me some memory. Give me 24 bytes of memory, because that's how much I need to represent this struct in memory. And what malloc is going to do is it returns to me an address, and I'm storing that in this start adder local variable. And then because in C, a struct's fields are packed as they're defined, so we can just run down the list here and pull out all of these elements of our hash, right? And stick those into an array, and they're now in order. And then I can write those to memory at the starting address. So when I called malloc, it gave me a contiguous block of 24 bytes, and that block of 24 bytes has nothing in it. It's probably garbage. It could be zeros. I'm not sure. We're going to write over that with all of the fields that we were given, and we're doing this in order to maintain struct order, right? We're using the pack function, Ruby's pack function, and we're saying L star just means take all, like L means a 32-bit unsigned integer. So it's saying take all of the items in this array and pack them into the 32-bit binary format, and then we're going to write this. So it returns a string, and then we write that into memory at that address, that start address that we got from malloc. Okay, and then we're going to return a new instance of compile info, and all that we really need to represent that is that address. And so we say new here, which invokes our constructor, our initialize function, and we're just storing that address in the class. So that's all you have to really do for this, right? We've got like a bunch of fields, we write them to memory, return the address, and we're good to go. Okay, so how do we use this thing in onig new deluxe? Well, we can just we can define a nice little extra function, make compile info. And what this is going to do is just give us a bunch of like sort of canned options. You could obviously change these or have these passed in somehow instead of doing it, like just canned like this. But this is kind of how I started because it was easier. I have no idea what num of elements means. I've looked through the code. I cannot figure out what that means. Everywhere in the examples, they just pass the number 5. And so that's what I'm doing too. No idea what that means. So that's the beginning of our regex class. So we're gonna create some compile info. That's all it does so far. Next thing we can do, and I'm gonna hand wave over these structs. These are just, you could just sort of follow the same pattern we did before. Look at the definition in the C code, define your Ruby class, pack the fields the right way. So first we create a pointer to a regex. I don't know why we have to do double pointer there, but that's in the code, so to follow that paradigm. We have an error info, and then we also want to create our pattern, and we have a UTF-16 string class that like takes your Ruby string, converts it to UTF-16, writes those bytes out to memory, and gives you back the address, just like we're doing with compile info. Okay, and now we can actually finally call the new function. So we're saying onig new deluxe, we're passing in, just like we saw in the function signature we showed, the C function signature, we're passing in the regex pointer, the pattern start and end addresses, the compile info address, and the error info address. So hopefully, if everything has been hooked up correctly, this will give us back either an error code, well, I guess we'll give us back an error code or 0 for normal exit. So we can check to see, okay, did this error code actually return correctly? If it did, then we can return a new instance of our regex thing and free some stuff in the process, or we can use this error code to string function, get back an error code as a string, and then return that or raise a runtime error for that. Okay, I know we're going very fast, but I don't have that much time. I'm so sorry. Okay, and then for Onix search was the last one we'll look at. So this one also, we have our C function here, and this we're gonna sort of, we don't need to really do too much here. We just need to define them here, Onix search, Onix region new. And to remind ourselves of what this looks like, we'll just paste it down there. So in our regex function, or regex class, we'll define another function called search. This takes a string. This is the string we want to match on. There's a start and end position, so we can determine, like we can say, like I want to match only within this substring of this string. So we create our UTF-16 string pointer. We grab a new region, and then we call search, and we can just pass in our regex, our start address, end address, and then we're gonna. There's the next two parameters are the range in the string. So like if I want to start at character 3 as opposed to character 0, that's how I would do this. You pass in those positions. Why am I multiplying by 2 here? Any ideas? Okay, that's because this is a UTF-16 string. UTF-16 strings are always 2 bytes. So the start address is going to be start position, which is a logical position, times 2, which is the number of bytes, the byte offset within the string to start searching. Same thing for end pause. And then that's essentially all we have to do for search. There's obviously a little bit more to handle that exit code. So we'll say, okay, in this case, we're looking for, and to notice that this -2 variable, this -2 value rather, comes from the C code. I had to read through that to find this. So if the error code is less than -2, that means an error occurred. And so we'll do the same thing we did before, error code to string, we'll raise that as an exception. If there's an Onix mismatch, in other words, I think that's -1. If -1 occurs, that means there was no match found. So we can just return nil. Otherwise, there was a match found. And so we can use our, there's another struct called match data that also Enigma defines. And that's, I haven't shown the code for that, but essentially we just pass in our string and our region, and it gives us back like this nice Ruby array of matches. And then we have to clean up after ourselves. Okay, so let's see if it works. Okay, great. We make a new regex, and you can see that the instance variable regex here is just a number. It's just an address into Wasm memory. It's not actually a Ruby class or anything other than a number. Okay, and then we can say re.search, and that gives us back this very nice match data object with our captures in it. So because ABC matched the A right there, it matched characters 4, 5, so the range of characters it matched. So yes, it works. Okay, I don't remember what this is. Oh yes, our test. Now I wanted to make sure that I, included a test here because of Jason's talk, and I decided to rename it a little bit.
Oh.
Yeah. So I don't, that seemed better than the previous version, I think. Yeah, I think so. All right, so we compile. We're going to do the same thing we showed on the previous slide. We're just going to match here, and we assert that all of these return the right values. I'm sorry, we checked the specification that this particular example adheres to the specification. Yes, thank you. Yeah, thank you. I thought so. I didn't think it was, fucked at all, but I could be wrong. All right. That's it. Thanks for listening. So that was a huge whirlwind. The code is also on GitHub. If you want to read through it at more leisure. There's 2 projects here. Enigma Wasm is the C library that has like the clang command in it and whatnot. And then Enigma Ruby is the bindings to that make it work in Ruby. Any questions before I step down? Do we have time for that?
So you got it to work. Ruby runs in the browser, no problem.
With Garnet, you mean? Oh boy, no, it doesn't. Opal is amazing though. Check out Opal. It's another implementation that does run the browser. Yes,
Yeah.
very good.
Like, why are you working on that? This is what, or working on that?
No, I mean, so Garnet's a really fun project, but I kind of hit a wall on it. I didn't know how to make any more progress, and so I kind of gave up on it. It was more of a learning tool anyway, if I'm being honest, right? So at some point it'd be cool to pick it back up again, but I mean, at this point, I think we'll just let it live on GitHub and, you know, die a dignified death.
Yeah.
In order to make it work, saying like the products in JavaScript. Right?
Yes, yes. Yes, I'm happy to, I can show you the JavaScript code if you're interested. Yeah. All right.
Right.
Thanks, everybody.
Yes. This is Alex's first presentation at SF Ruby. And he works at Toptal and contributes to open source. Yeah, tell us about that.
Yeah, I have a slide, so thanks. So apparently there is a lot common with Cameron's talk and mine. I just realized that. First of all, we use the same slides, the same template, but I changed colors. But if you look at it, it's actually quite the same. Yeah. I'd also talk about things that compile, and Bazel is the thing he used to compile. There was something else, but I kind of forgot. Let me just start. So we're going to talk about Bazel. Very happy to be here and have the opportunity to talk about. My name is Alex. I work as a quality architect at Toptal. I also do a lot of open source work. I have written a small clipboard manager called Mackie for Mac OS. It's very popular. Maybe some people here use it, maybe not. I also maintain Selenium. So you probably guys all know the Selenium project to some extent. I'm responsible for everything related to Ruby there. And Bazel, we use Bazel there as well. Apart from that, I have started a project called Alumnium.ai. It's an open source project for AI-powered test automation. You're welcome to check it out, but it's in Python. It's kind of not relevant. But for the purpose of this talk, what matters is I'm also a member of the Bazel Rules Special Interest Group, where I maintain everything like the support for Ruby language within the Bazel ecosystem. And that's what we're going to talk about today. So does anyone here knows what Bazel is? Okay. How do you know, Cameron, if I may ask?
Previous company used it. I'm not sure. It's for that was to build a large project.
Yeah. Okay. I remember the third thing you mentioned that Figma uses is written in C++ and compiled. So Figma uses Bazel. A lot of different companies, Stripe uses Bazel, and many different big tech companies. Bazel is just a build and test tool. That's kind of it. So we have Rake, we have Make, we have a lot of different tools for building. Bazel is just one of them. But it was created at Google, and it was created at Google. You can imagine that it has very specific requirements in terms of how it works. Google has monorepo, and Bazel was created for monorepo specifically. And then at some point it was open sourced. And now it's, I think it's an Apache 2 project. So it's a build and test tool created at Google, designed for monorepos. By the way, does anyone here not know what monorepo is? So a monorepo is just like when you put all your code in a single Git repository, or maybe a different version control, all your languages, or pretty much everything. And then it creates a set of challenges with tooling, and Bazel is a solution to many of these challenges. So it's for monorepos. It's polyglot, meaning it supports all different languages. In your repository, you can have Java, you can have Python, Ruby, obviously. You can have Rust, and it all works with Bazel. And because it was created at Google, it is extremely efficient. It is extremely scalable because it can support huge monorepos like mega repositories with millions of source code files. And it kind of created a set of design choices and trade-offs that they've done while developing Google. And one of them is that it has to be hermetic. And by hermetic, I mean that when you use Rake or Make, you use it through your operating system, right? like you install make on your operating system and then you use this binary. But in Bazel, everything is managed through Bazel. So like if you want to compile something with Bazel, it will actually download compiler, put it into sandbox, and it won't really pollute your operating system. It will use that. And the last point, we'll get back to this, remote caching and remote execution, kind of show you through the demo why it is important to mention. Okay, so Bazel is a build tool. So what is build in Bazel? And if there is one thing that I want you to take from this talk is that build in Bazel is just take a bunch of inputs, run some action over them, and produce output. So inputs are files. Maybe you have some Ruby source code like add RB, remove RB, and you have a gem binary. These are the inputs. And then you run action with this input. So maybe you run this gem binary and you give it a build command and you give all the source code files and it produces a gem file. That's your output. And then what your action produce as an output can be input for other actions. So maybe you build several gems and then you want to package them in your Docker image. So you run docker build over these inputs and that creates a tar file, which is a Docker container image. And that's kind of, so you have a bunch of inputs, you run some actions, that produces new files that can be inputs to other actions, and so on and so on. And I mentioned that Bazel is also a test tool, and test is kind of very similar to that. You have inputs, your source code, your test files, your maybe the rspec binary, and then you run rspec, and it gives you some kind of test result that, and an exit code, of course. And that's pretty much it. And I guess you can see the pattern that all your build targets, all your tests is essentially becoming a huge graph within your source code. So some files are inputs for some actions and some files are inputs for some other actions, and they kind of all wrap up together in one huge graph. And Bazel creates this graph, builds it for you, keeps it in memory, caches it, and then operates over it. It's a graph, and it's very efficient in a sense that if, for example, you work on your source code and you change the test file and you tell Bazel, hey, build and test everything for me, it knows that, okay, it doesn't have to run gem build because you didn't touch these files. You only change the test, so you have to rerun rspec, and you don't need to run docker build or gem build because it's not relevant. I also mentioned it's polyglot, and because inputs and outputs are just files, it can be anything, right? So maybe you have some static assets that are not relevant for testing and building the gems, but they are important for packaging the Docker image. Or maybe you have front end that you want to go through some JavaScript tool chain and maybe minify. And again, if you run your specs, it doesn't matter. It's not an input, but it is important when you package everything inside the Docker build. And it's polyglot, and when I say it's polyglot, it's truly polyglot. So it has built-in support for Java and Python. These are, I guess, because Google uses those extensively. And whatever programming language you have in mind, name it, there is a support for it. There is Node.js, TypeScript, Go, Rust. Rust has native support for compiling to Wasm, by the way. There is special rules for Docker, Open Container Initiative, Helm, and Ruby. So let's talk about Ruby. That's kind of why we're here. So Ruby is just a module for Bazel that provides native and decent support for the programming language. So as I mentioned, Bazel would install all the dependencies for you. So it would, the rules, Ruby would install Ruby, it would install dependencies through bundler, and then provide some kind of conventional common interface that you would use to build gems, run tests, run Ruby scripts. And I'll show all of that in a second. But basically, you can think of it as just a module within the ecosystem. All right, demo. Let's try to do that. And is that big enough? folks in the back, can you see that? Okay, a little bigger. Is that better? Yeah, fine. Okay. If it's not good enough, just let me know. Okay, so for the demo, I have a Ruby gem. It's fairly, I guess, straightforward. So we have some gem spec. It's a calculator. I didn't came up with anything better than that. There is some files like calculator with the two classes to add and subtract, and it's very simple. Just basic operations, basic math operations. There are some specs for them, like calculator add works correctly and subtract works correctly. So we can run this. It works. And then we have a gem file with our spec and Rubocop. So probably I have some Rubocop. We can run it. Yeah, fairly easy, right? Nothing fancy. And yeah, by the way, I use Ruby 3.3. Maybe that matters, maybe not. But yeah, I'm kind of trying to keep it simple. So let me start by adding Bazel to this and kind of show you what it does, and then hope we get to a point why you might want to do that. Like why does it matter? So we start by saying that there is a special file called module Bazel. It's basically a way for Bazel to say, okay, this is a Bazel workspace. This is a root. And there you declare what kind of languages do you need. So here we say we need rules Ruby, and it will install the module. And then we say, please install Ruby for me. So just read it, what's in Ruby version file, install it, and then fetch some dependencies through bundler. So we need gem file, we give it gem file log, the gem spec, and the version RB. That's because the gem spec requires version RB, so we have to explicitly say these are inputs. Okay. And then we have a build file. And build file is just where you actually define the targets, what you want to build, what you want to test. So if I tell Bazel now to build, and I use triple dot, this means recursively build everything. It's not going to do anything. You can see that it created some folders. These are symlinks for convenience, but it hasn't done anything because there are no test targets. And even though we said we need Ruby, we don't have any targets that require Ruby. So nothing has happened. So let's try to do that. Let's try to add some target. And for example, what we're going to do is, GitHub Copilot is smart, but not smart enough. The language, by the way, the language is called Starlark. It looks like Python. It's not really Python, but it has things like cycles and loops and functions. So let's say we're going to build a gem. Okay? So let's call it calculator. And it needs some inputs. Inputs are source code files. So we're just going to take everything inside the lib folder. So this is, I guess, a regular glob expression. No dependencies. We also need to say, where is our gem spec? And that should be it. So let's try to build it. And let's see what happens. It worked. Yes. Awesome. So you can see that it built a gem, and it actually prints the output from gem command. And it put it somewhere in Bazel bin folder. So let me refresh that. Yeah, you can see it over here, and maybe we can unpack it and see what's inside. So there is this. Well, these are our source code files, right? Nothing else. This is everything that we declared as an input. So let's remove that. What happens if I do it again? Nothing. It says, you see, it does not attempt to build again because nothing has changed in the inputs. We said that for these files, do this, and as long as nothing has changed in these files, it's not going to do anything because what's the point, right? The result is going to stay the same. Okay, so building gems is nice. What about Rubocop. Let's try to add Rubocop. So Rubocop is a test in a sense, like you run it, it returns an exit code. One if it failed, an exit code. 0 if it passed. So let's just run Rubocop over the same source code. Maybe let's add specs. Yeah, I think it kind of makes sense. Maybe let's add gem file. I think Rubocop runs over gem file and gem spec as well. So these are all SRC files. These are all inputs for Rubocop. And in order to tell Bazel to actually run Rubocop, because it's maintained by bundler, we need to use a Rubocop binary that is available through bundler. It's kind of an LS here. So what is here is the same thing that we have used here. So it can be anything, but the main thing is we need to tell which binary we run, and we need to tell that we need the whole bundler dependencies to do that. So if we run now, let's do Bazel test, triple dot, again, run all the tests that are available. You can see that it actually installs bundler and installs a bunch of gems, and then it runs the tests and it fails. And it failed because there are some legitimate offenses. But I think it failed because I did not use rubocop.yaml as an input. So let me just add it here. There is this. You might be wondering why it's not part of the SRCs field. It's a kind of decision that Bazel has made at some point that SRCs are just language-specific files, like Ruby files in our case, and data is everything that is not. So, but essentially it's the same thing. It's just a convention. So we run the tests. Okay, cool. They're passing now. And you can see there is no output. By default, if it's passing, there is no output, but we can treat that. And yeah, you can see there is this regular Rubocop. Okay. Cool, it works. You might be wondering what's the point to do that? Like you can still run bundle exec Rubocop gem build. So let's try to make something a bit more reasonable and fun. Let's try to add some specs. So to add specs, I'm going to create a build file inside the spec directory. That's where we are, where we host all our tests. And let's add the same RB test, and let's define a test for our first spec file. So we're gonna call it add, and we're gonna include our spec file. Oh, sorry, that's add spec.rb. And similar to how we used Rubocop here, we need these two fields. Main rspec and bundle. I think that's it. So let me try to run all the tests inside the spec folder. You see that it ran spec add and it failed. And if we look at it, it failed because it actually cannot load calculator. And it makes sense because for this test, all we have is just the test itself. So the way Bazel works is that it will take all the inputs, put it in a separate folder in a sandbox environment, isolate it from your operating system, and then run rspec there. Because of that, there is no calculator there. So we have to declare somehow a dependency over it. And in Bazel, you can't refer to files from your parent folder because that would break the isolation and that would potentially allow you to escape from the sandbox at all. So the way you would do that is by declaring the proper dependencies inside this inside the lib folder. So let me just quickly show you how you would do that. So again, we create a build file. This time, let me just copy this time we say it's not a test, it's just a Ruby library. And what we're gonna do is have, we're gonna declare a library for each source code files. You can join them, but for the purpose of this presentation, we want to have them separated. Okay, sorry, typo. Yeah, looks good. Yeah, I think it looks good. Yeah. And then we expose it the calculator.rb, and we need to do the same for all the files inside the subdirectory. So let's do that. Let's add one for add.rb. Let's do the same for subtract. And let's do the same for version, even though we don't care about it that much. So, and now if we switch back to our tests, we can say that it actually depends on calculator.add, calculator, there is no such thing, calculator.subtract, and the calculator file that is in the original folder. And try to run the test again. So now Bazel would think that, okay, I need to put these files to the same folder too. And it fails because there is another concept in Bazel called visibility rules. And we'll get back to it. I just wanted to show you that it fails. By default, you can't refer to things that are not publicly declared, which kind of might make sense when you work on a huge code base. So let's just fix that real quick. We're just gonna say that everything is public inside this folder and everything is public here. And we run the tests and finally they're passing. Okay. Cool. Again, why would you want to do that? Makes no sense. Just run our spec. So let's add another test for subtract. And we're going to run the subtract spec. Actually, we don't need subtract for add-in tests, right? It is not used there. Likewise, we don't need add RB in our subtract spec. So let's try to run this two again. Sorry, typo. Okay, so it ran two tests. One thing you can notice is that it ran two things, not one. This is because by default, every test is run in its own process, in its own directory, with its own set of inputs. So if you have a lot of tests, Bazel out of the box would allow you to parallelize them and scale them as much as you want, like or use all the cores. But another thing that you might notice if you run the test is that it says it's cached. So what does it mean? It means that Bazel took all the inputs, calculated them and cached them, run tests, and as long as you don't change the inputs, it's not going to rerun the tests because nothing is going to change. So if we go to, let's say, add RB and doc, add some changes and rerun all the tests, you can see that subtract is cached. It's not being rerun, and you only rerun tests that matter. And that is one of the most important things with Bazel, is that you can work on your source code as long as you build everything properly. You can work on your source code and you can run all the tests, and it will only rerun things that make sense, that matter for this particular, based on your changes. And another thing that is very important is that because you can't just refer to classes and constants that non-exist in your test, you can you can kind of set the boundaries within your application. So like, I know many people use Packwork these days, which provides you a way to isolate part of your source code in a particular folder and not allowed to use it. So think of it as Bazel provides this out of the box. It's kind of on steroids, because if for some reason I say, well, subtract now depends on add, and I try to run the test will fail because there is no such file. And I can fix that. Of course, I can say that actually subtract depends on add, and now my test is passing. But if you compare it, for example, with packwork, what you can do easily with Bazel is you can ship everything to production and not worry about things breaking because you refer to constants that non-exist, but you can also run all your tests and catch violations that catch the code using some other code it's not supposed to be using. Okay, and yeah, let's revert that. It didn't make much sense anyway. But yeah, so that's the main thing with testing. So you cache everything, and then you keep track of changes. So for the demo, a couple other things I wanted to show is that once you start adding these build files, and you kind of takes a bit of work, but it's not very complicated. But then when you operate on large code base and you have multiple teams working with the code, you can start using the same build and test tool as a way to notify when you, for example, want to change something. So like if we can add deprecations and they will be printed, we can declare actually the whole source code as let's do it private, and then we will see the same errors during the test execution as you've seen before. So yeah, think of it as a packwork plus a test runner plus everything, like a build tool, and that works out of the box and with a lot of extra nice things. I wanted to mention, I mentioned the remote caching and remote execution, and I want to kind of explain why I think it's very important. So you've seen how things are being cached on your machine. So you run tests once, and then you can rerun them as many times as you want. It's not going to do anything. But because everything is input and file, you can take this cache and you can put it in the cloud. And out of the box, Bazel, for example, can put your local cache to Google Cloud Storage, and then some other developer in your team would clone the repository, run the same Bazel test, and as long as their inputs are the same, it's not going to, again, it's just going to download the cache, and he's not going to run these tests. Likewise, take it further. Everything is an input and file. Why not we just put it, like take the inputs, put them to remote machine, run the actions there, that will produce some other files, and then we download these files. And that's called remote build execution, again, supported natively by Bazel. There are open source servers you can run in your infrastructure. There are paid services that provide that. But dev containers and a lot of tools exist for remote execution, and Bazel kind of have it out of the box, with a big difference that you don't really containerize anything. You keep working in your local computer, you just change the code in your IDE, and then Bazel would package that, upload, run something intensive there. Scale, you can run the tests maybe with 100 cores parallelism. That all happens inside the cluster, and then you get the results back. An example for that, Selenium I mentioned, is a massive monorepo. So we have Java, we have Rust, Ruby, C++, C#, all of that works through Bazel. And our CI was taking like several hours to run everything. And then once we adopted Bazel, once we started using the remote caching, remote execution, now you open the PR and it runs all the tests, and it gives you like 5 minutes. It runs everything that you actually care about because you changed these files, and the rest is just cached. And it's so powerful concept, having the inputs, caching them, and producing the outputs. So I think that that could be compelling, right? So we have a lot of parallel tests and different solutions for that. And Bazel had this out of the box. Yeah, so I think at this point, that's mostly it. I just wanted to say thanks. Some links for Bazel. There is a GitHub repository for the rules Ruby. We have a Bazel Slack with Ruby channel. So if you have any questions or you'd like to give it a shot, you can go there and ask questions. I'm there. And then there is my email. If you're not a fan of Slack, just shoot me a message. Thank you very much. I hope I managed to convince you that there is other build tools except for Rake out there.
Question about the adoption. I think that's what people think about. So you mentioned Selenium case when you guys were kind of adopting Bazel, and how much effort did it take?
I would say it wasn't 2 engineers, I think, working on that. And Selenium being an open source project, you never have full-time people working on it. But we have Stuart, who is one of the core contributors of Bazel, so he knows it very well. But I would say it took us maybe a year, and that's kind of painful. But again, Selenium being very specific, we have a lot of languages, and we actually written the rules Ruby because nothing like that existed for Selenium project. So the adoption is complicated, and I would only suggest to do that if you have a monorepo with multiple languages. Then it's worth it. Otherwise, no, just use Rake. There's no point.
For like a typical CI/CD pipeline, say you want to like build a Docker image and then push it up somewhere, how does Bazel fit in? What's like the last step to get your image live or something like that?
So what we did is you use rules OCI. That's a thing that takes your inputs and builds a tar, that a Docker image. Then that is pushed to repository, like a regular Docker registry. But on top of that, it's used as an input for Helm package. So in a release pipeline, you just run something like Bazel run deploy. That will build the image. That will then trigger the Helm. And at that point, it will finish.